So everybody is already aware of Bitcoin. So anybody already trading in Bitcoin or any other cryptocurrencies? Nice, a couple of hands. Very good. So it all started around 9 years back. In 2008, we hear about something called subprime collapse. You know, in the US, there was a lot of financial institutions went bankrupt, Lehman Brothers and all those. And soon after those events, a person named Satoshi Nakamoto, that's a pseudonymous name. No one really knows who the person is. And he came up with this paper of Bitcoin and how a digital asset, a digital currency can be used. But you know, when he launched this paper, I think almost people laughed at him, people rejected the idea, they dismissed the entire idea itself. And since then, it's around 9 years now. And now we see Bitcoin is one of the top cryptocurrencies, having a market capitalization of around $100 billion. You can, yeah. So, and since then, there are a lot of other currencies also for Ethereum or Dash or Monero. So, we see a lot of other cryptocurrencies as well. So, that's a bit of history about Bitcoin. So, today we are going to cover a bit of basics about the Bitcoin, the ideology behind Bitcoin, the blockchain, which is an underpinning technology of Bitcoin, and then Harsh will touch base to the applications of cryptocurrency, the ICO part of it, the legal aspects. So before we get into currency, especially cryptocurrency, let us understand the currency part of it. So there is a fiat currency that we are using currently, which is controlled by the government itself, the central banks, which is fiat currency, right? So every country has its own way of supplying the currencies, right? And the fiat currency also has its own characteristics. Like it is owned by the country. It has security aspects, like it is centrally controlled by the central bank. It is inflationary. There are some security aspects to prevent fraud, counterfeiting in every fiat currency. But irrespective of that, it is also possible to counterfeit, right? And that is why the law enforcement is needed. So, what are the security characteristics of the fiat currency? We know, like in the recent, after the demonetization phase, you know, we must have seen this in the newspaper. With the new note, you get so and so security features, right? So that's with the fiat currency. So what about the cryptocurrency? So before we move ahead, we also know that how this evolution of currency has occurred so far. The earlier people were doing a barter kind of thing and then moved on to paper currency and plastic currency in terms of cards. And now we see this new age of cryptocurrencies in the form of Bitcoin as the first killer application of blockchain. So, what is this Bitcoin? Has anyone heard about it? I see many hands. If anyone wants to talk about it? No? So, it's a digital asset, it's a digital money, but it's not, you know, it doesn't stop there. Okay, it's not just digital money, it's a way to transfer funds from anywhere to anywhere. It's an international payment system. Okay, so Bitcoin focuses on the payment part of it. It's an international network of payments. It is not owned by any government. There's no central control like RBI with Bitcoin. It doesn't rely on any bank. Okay, it's a peer-to-peer mechanism for transferring funds. And the most important part of it is like people feel it, the industry feels that it is a historic movement. Since it was launched, you can say that it is another internet. It is as big as that. So before we get further and understand the cryptocurrency, we need to know, are there people from the engineering background here? Yes. Okay, computer engineering. So we will be able to understand few of the concepts like cryptography, basic stuff. Like when we talk about cryptocurrency, we need to understand what are the building blocks of cryptocurrency basically. So cryptography plays a major role in cryptocurrency, and it's basically there are two building blocks of. Okay, let me switch back. Okay. Cryptocurrency is a subset of alternative currencies. Okay, alternative currencies to fiat currency, and in 2009 it was launched, and Bitcoin is the first popular cryptocurrency. And since then, there are a lot of other alternative currencies which are launched. Like because Bitcoin, the source code of Bitcoin is completely open on GitHub, anyone can go and fork it. So anyone can create their own currency. I can say I want to create Ajay coin, so that's possible. Okay. So with that notion, there are a lot of altcoins you can see available today. So these are few of the popular altcoins available, like Ethereum. There is Ripple, Litecoin, Dash, and now if you can go and search, there are currently 1,000 plus. I mean, to be specific, there are around 1,113 alternate currencies available today. So when we talk about cryptocurrency and when we talk about cryptography specifically, we need to understand these two aspects. One is the hash function, the hashing aspect. The second is the digital signatures. So people from computer science background will be able to understand these areas. So what is hash? Can anyone put some light on hash functions? You need mic? So you are saying it's an address. Yeah. Yes, please.
Numbers.
Okay.
Value.
Anyone from computer science background?
Yes, power to my
It's unique ID to each whatever you are applying.
Okay. So hash function, there is some input you can see in the blue box. There is some input given to the hash function. In the yellow box, you can see it's a cryptographic hash function. It's a mathematical function basically, and it outputs something called digest, which is nothing but an alphanumeric string. Okay. The fun thing about it, about this hash function, is the input is unlimited. Okay, it can be just one word input. It can be a sentence. It can be a whole document as well. Okay, you can go to the hash function, and the resultant output, the digest, is always 256 bit. Okay, so there is a limitation there. Okay, so what are the general properties of this hash function? Is the input can be any string of any size, or produces a 256 bit output. But there is a security property here to this hash function, which is it is collision resistant. What do you mean by collision resistant? If you look at these multiple blue boxes, you can see the message has been changed a bit, little bit. Change is done, like some space or some character is added, and if I give a modified input to this hash function, the digest will change. Even if I put a space into the input, the digest will be different. Understand? So, what is this collision resistance? Is it possible that for two different inputs, the output is same? No. That's not possible. So, though theoretically it is possible, if we take years to calculate that hash, we'll come to that. So, what is collision is? The inputs that we are controlling, input 1 and input 2, can it generate a same target hash? If it is doing that, that means there is a collision. Okay, so these hash functions are collision resistant. But is there any possibility of collision? For a hash function of 256, you will have to compute a hash function 2 raised to 256 plus 1 times in the worst case. And that's a very huge number. So, how huge it is? Like for a computer which calculates 10,000 hashes, it would take 1 octillion years for that computer to just calculate 2 raised to 27 kind of hashes. So, even if theoretically it is possible, practically, it's impossible. Even if you combine all of the Google's, Amazon, all data centers together and put all those computers for this hashing, so that's not possible. So now we come to a point where we need to understand the blockchain aspect, the underpinning technology of Bitcoin. Hash is one part of it, but when we talk about block, it is basically a set of transactions. Like Ajay is sending some money to Vijay, and this transaction, needs to be passed. It's a peer-to-peer transaction. This transaction needs to be included in a block, and these blocks needs to be chained in a sequential manner. That is called a blockchain. Okay. So how this block, the data structure of the block works is it's kind of a linked list. Like people from computer science background will understand linked lists and binary trees, right? So what we see here is in each data block here there is a data, and there is a pointer to the previous block, to the previous data block. So which is nothing but a hash of the previous data. If you can see here, hash of previous data. That's how the chain is created. Okay, linked list works in the same manner, right? So same concept is used in. So this is called a hash linked list. Okay, it's not a linked list basically. And second important point to understand here is it is tamper evading. So what do you mean by tamper evading? So what if we tamper this hash? What if we change this data?
The whole chain will get disrupted.
Exactly, because we have seen the hash function, and when we make a small change in the input, the hash of the digest will change, right? So if I make change here, the reference here will change. That will break the chain, right? So I cannot simply go and tamper it. So even if somebody is tampering, we'll know that. Okay, so the blockchain uses the same concept of linked list, but with the hash pointers instead of regular pointers. And there's another concept that we need to understand, which is called Merkle tree. And because in one block there could be hundreds of transactions. Okay, in one block. So with this structure, when I need one hash for the reference here, I need one hash only. Okay, for reference of the previous block. So what if I have hundreds of transactions in a block? Do I need to reference all hundreds of transactions here? Hundreds of hashes here? No, I just need one hash, right? So in that case, how to calculate one single hash? So let's assume this L1, L2, L3, L4 are different transactions. Okay, they are going to be participated in the new block. Okay, so to calculate one single hash for all these transactions are clubbed together in a pair. and from L1 and L2, hash is created for L1 which is has 0 0. Another hash is performed for L2 which is 0 1, and for this pair again, one more hash is created. Similarly, you're waiting this point, right? Similarly, these two transactions are paired together, hashes are created. Hash of these two hashes are again created, and finally, only one hash is created, which is called a top hash, the root hash. And this single hash, this top hash of all, it could be 100 transactions, it could be more than 100 transactions, depending on the size of the block. One single hash is used as a reference here. Am I making sense?
Yeah.
Okay. So this is called as Merkle root. Alright. What if a transaction of L3 is changed? What if the data of L3 is changed?
The top hash will differ.
Top hash will
The entire tree will change. All the hashes will change. And the top hash changes, and this blockchain, which is referring, which is using that top hash, will break. Correct? That's how the blockchain is temporary.
the chances of replication won't increase if we are creating one particular hash for all the transactions.
We do not have choice of what hash needs to be there. If hash is generated, you cannot say that I need so and so hash. The hash function decides what hash needs to be generated.
I just found it.
Yeah. Okay, and it is unique always.
But there are different transactions, right? And different
Right.
hashes for that particular thing.
Correct.
And say, for example, there are 4 transactions and 4 different hashes for that 4 different things.
Correct.
Then one particular hash will be generated, and that will be unique to those 4. So that means 4's capacity is reducing down to 1, right?
So what we are combining hashes.
Are you saying
Okay.
that this part will be remain very minimal
Yes.
as compared to the input which we are
Yeah, so it means its chances of getting repeated, you said, right, 2 raised to 56, something, that number. Only then it will take around XYZ Oculus years for copying, then it will reduce.
No.
Reduce, right?
No, the hash function is same. Okay, hash function is not changed. The characteristics of the hash function is not changed. Only the input is changed. So for the hash function, what you are giving as the input is combined hashes of these two transactions. So just the input is changed. Okay. Did I answer your question?
Yes.
I think he's trying to decrease the calculation number of calculation which happens to
It doesn't. It doesn't affect the
number of
the possibilities of collision. Okay.
So, if there's the same message being executed multiple times, so the digest for a particular message would be
The
the same.
same.
So that the number of times I repeat the same message, the digest would also be the same.
Exactly.
So,
So it is a deterministic output always. So is this clear? And the second building block is digital signatures basically. So I think many of us are already using concepts of public key or private key, if you have heard of it. Anyone heard of public key, private key concepts earlier? Okay. Very few. Okay. So basically, the digital signatures plays a major role in any cryptocurrency. In fact, that's the second building block, and you can say it is digitally analogous to your hand signature. It is as unique, as when it is created, the new key pair is created, where I have a public key as well as a private key. So I share the public key with others, and I keep the private key with me to sign the messages. Okay, so what we can do with these digital signatures is you can make your signature, and another person can verify that whether the signer is the one who claims to be assigned. Okay, and this signature, digital signature, which is tied to a particular message or particular document, it cannot be used. Same signature cannot be used again and again for different messages. Okay, once I sign and the digital signature is generated, it is attached to that particular message. Okay, so it's not reusable for different purposes. So this is the process of creating a digital signature. There is a secret key and public key. This generate key function requires a key size, and it gives you two things. One is the secret key, which is basically a private key, and the public key. The sign function requires your private key, secret key, and the message that you want to sign. Okay, and it gives you a signature, digital signature. And whoever is receiving your message, and the person, if the person wants to verify that for verification, what you share with the person is your public key, not your private key. Okay, and the message that you are sending. And the third part is the signature, which is attached to the message. So the result, what you get is whether the signature is valid or not.
Key size is the default size, or you can variably define that.
Key size is the default size.
Default size 128.
Yeah. So that's the process of generating your signature. There is a signing process as well. When we sign a message or a document, what we do is basically, let's say this is a message. It is sent to the hash function. Okay. The hash of the document is generated, and when we encrypt it, we need a private key, and the resultant output is a digital signature. I hope I'm making sense here. Is it too technical?
Yes.
Sorry.
Okay, we can skip slides if you find it too technical. Okay, what you need to understand here is digital signatures are an important part of blockchain. Okay, so whenever I'm sending something from one person to another person, I need to sign it. Like, for example, I'm sending funds. I'm sending bitcoins from my wallet to his wallet. I should have an authority to send it, right? I should sign it. For signing purpose, I need to have my signature.
So if my cryptocurrencies are stored in multiple wallets, every wallet generates a private key and a public key.
Exactly.
So even that can be replicated.
Yeah, every wallet you create, it creates a pair, public and private. So shall we skip few of the slides if you find it too? And this is a process of generating a Bitcoin address. Your Bitcoin address is like consider your email address. I want to send you some funds, so I need your address. So using your address, I can send funds to you. So the address is generated using the public key. Okay, your public key, and then you can give me your address, and I can send you funds. It is one-way hash. What do you mean by one-way hash is, if I get your Bitcoin address, I cannot get back to your private key using your Bitcoin address. That's a one-way hash. And Bitcoin address is, this is an example of the address. It's just alphanumeric string. Can be shared with anyone who is sending you the funds. It's produced from the public key. It's also called as recipient address. And let me skip this because it is a code now. How to generate a Bitcoin address. So we talked about Bitcoin as a decentralized currency. Right? The centralized currencies that we know of is Indian rupees, US dollars, euros. Those are centralized systems, centralized currencies. So when Bitcoin was introduced for the first time, they said that it is decentralized. So what do you mean by decentralized? There are a few examples that we need to understand first. What are the decentralized systems or centralized systems that we know of?
Banks.
This we can understand, right? It's not technical.
Yes.
So the banking system, the governments, Amazon, it's a centralized system. Right? The money transfer systems like SWIFT network. Centralized means some organization is controlling the system. Okay. Even Aadhaar is a central system because there is one body which is controlling the entire system. And an example of this decentralized system could be a government. Though there is a central government, there are local bodies as well in every state, in every district. Some more insight about centralized versus decentralized. I mean, we just compared the local governments and all. And this third point comes up, which is called distributed. So, what's the difference you see here between decentralized and distributed? What's the key difference here?
There is no interconnection.
In the boundary, there is no boundary.
There is no
boundary.
It's much
There
more
is no
connected
boundary.
and distributed.
Say again.
It's much more connected and distributed. All the dots are connected to much more.
There is no intermediary. Very good point. There is no intermediary. So in centralized system, there is single point of failure. If Aadhaar system goes down, everything goes down. I'm just giving example. Okay? Even in decentralized, there is a single point of failure, but it is decentralized. Okay, the impact of the failure is among this group only. Okay, but in distributed, what if one point goes down? Will it impact the other areas?
No.
So in distributed, basically there is no central control. Every entity here, the dot, black dot you see here, is having equal right. They are equal. And that's how Bitcoin is designed. That's how the D blockchains are designed. So if you compare it with existing systems, maybe okay, we can take an example of telecom as a centralized system and internet as a decentralized system. Is internet owned by anyone?
No.
No, it is. How do we say it is decentralized? But every country has its own control, like China, as an example. But blockchain is a distributed system where there is no central control. All nodes are equal. And this one node represents a person or a system, a subsystem we can say, which is called miner. Sorry about this typo, it is miner, N-E-R. So it's also called, in case of Bitcoin, it is called as miner, who has a certain set of hardware which is used to verify these transactions. For example, I am sending funds to you because in the centralized systems, if we are using, let's say, Axis Bank, and your bank is different, my bank is different. So in between us, there are two banks who are verifying our transaction. But in case of distributed network, who is going to verify the transaction? Whether if I am sending $100 to you, do I really have $100 with me? Or who is going to settle the ledgers for both of us? Okay, withdraw from one account and deposit in some other account. So somebody should be doing that, right? So that's called transaction verification validation. And this guy does the transaction verification and validation. Okay, with a special hardware, special processes, special software, the special process for mining blocks. Getting these transactions into a block, building a new block, and attaching the new block to the blockchain. That's the process the miner is doing.
So for the execution of any function, how many miners should verify it? Is there a minimum number?
Right. So in general, 6 to 7 confirmations are needed for a transaction to be passed.
So transaction is complete. But for example, I did a transaction last month. It still receives confirmation. Now it has received 35,000 confirmation.
35,000.
Yeah, it
Okay.
keeps on getting confirmation. So why is that?
Okay. So even if you have successfully transferred funds from one account to another, so what happens is when the minor nodes are increasing day by day, they need to sync the blockchain from the current because if I'm a new miner, let's say, my blockchain is zero current. My blockchain database is at zero state. And the current blockchain, the Bitcoin blockchain has let's say 100 GB of data, right? So I need to first download the entire ledger on my node. Okay, and then I come to the latest point of the current transaction, and from that point onwards, I can start mining. I can start creating new blocks. I can also verify earlier transaction as well. If I am doing that verification of blocks of earlier transactions, then the confirmation count may increase. Okay.
So
Yes.
a distributed system makes the Bitcoin as a whole very volatile, right?
Why do you think so?
Because if it is at the same time, if it is independent, it is also interconnected, right? So if
Right.
somebody perceives that the market is not that much high or something of that sort, then each and
What do you
every,
mean by market is not high?
I mean, I'm not getting the right word, but if somebody goes down, then like it's in the air, nobody is controlling it, something of that.
Okay. So I can understand what is your question, specific question.
So it makes it volatile. So so there are articles which says rather,
Why it is so volatile?
yeah, it's
Okay,
a books
okay.
kind of a thing.
So you're talking about the value of the Bitcoin, why it is so volatile.
Volatile.
Okay, it's due to the speculation. People invest a lot into it, assuming that they will get returns. Okay, so that's another part of it. Okay, but that's another characteristic which is investment oriented. Okay, so we are here to understand the technology behind it. Okay,
So how to calculate the time, like the time constraint, like to verify it needs some time, right?
yeah.
So
So Bitcoin transaction normally takes 10 minutes.
okay.
Okay, a block creation time is approximately 10 minutes. I'm sorry. So that is why a block, your transaction confirmation will take that much time.
Well, sir, I have one question. It usually takes more than 10 minutes.
Yeah.
Because
It
they
all-
need to be validated with your transaction. Means any wallet or exchange takes time.
Correct.
They validate your 5 to 6 times your
Correct.
transactions, and then it
Sometimes it takes an hour as well, or more than 1 hour as well.
Yes. So it should not be like that. It should be in 10 minutes.
See, if you compare this with the traditional systems of bank, you cannot compare it because it's not a central,
No, I'm
centrally
not
controlled
comparing with
system.
the
Because
banks, but
when you use UPI or IPS, it's immediate, instantaneous transaction.
yes.
But you're paying for it, right?
Yes.
From US, if you want to receive USD,
Also, we are paying for this. There is minimum charge.
yeah, see the difference.
Difference is more, but
Yeah,
we are paying this to.
of course you are paying because you're using the network, right?
Yes. We are paying exchanges, and there are different charges for that.
Can anybody tell me the difference between what we pay for a remittance charge from, let's say from US, I'm receiving $100 in my Indian bank account. How much I have to pay
Around
versus,
$10 to $12.
yeah,
Around 10% you have to pay.
right. How much we pay for Bitcoin?
0.001.
It varies, but it's not that 10-15%. It varies. But if you are receiving $1 lakh, or if you are receiving $1, for Bitcoin the price is same. For other currencies, the price is a percentage.
But in India, some wallet, my unicorn like wallet, they are taking charges in case of percentage of your transaction.
So that's different. I'm talking about Bitcoin.
Yes.
I'm talking about the Bitcoin network. Bitcoin network doesn't charge you. Okay. The exchanges may charge you on the percentage, but that's that you're trading, right? Okay. Any other question? Yes, sir.
1100 different
Altcoins.
issues. So those are basically platforms.
Those are what?
Basically platforms.
Yes, those are alternate coins, just like Bitcoin.
With any of one, you can create an account and
Yeah.
then you can enter transactions.
They are not interconnected
Okay.
per se.
Right. So
But there are few exchanges which will help you to convert one coin to another. For example, you can buy Bitcoin and you can convert it into Dash or some other coin. That's possible.
at first go when you're creating your account, you have to buy Bitcoin, right?
Yeah. So
You have to pay for it.
Yeah,
The fiat currency you say,
of course.
right? And then
It's like buying gold.
yeah. So when you are done, suppose you don't do anything with the Bitcoins and all, and you want to sell, so again
You can go back and sell.
You can okay. It's similar like shares and all.
Yes, it's like commodity, you can say,
Commodity.
for the sake of understanding. Yes.
Sir, like there are a limited amount of Bitcoin. So
Yes.
and day by day the amount in the market is increasing. So what will happen when all the Bitcoins are
Consumed, supplied. There are limited 21 million Bitcoins only can be generated. And if all of them are mined, then we can transact using the same number of Bitcoins available. Using it is infinitely divisible. Okay, we can divide into Satoshi is a minor unit like that we can use. So it is infinitely divisible. So no need to worry about what will happen when 21 million Bitcoins are consumed.
Among those 1100 and odd
Alternate coins.
alternate coins, which one is faster and safe? You've been working
Faster in the sense in transaction processing.
transaction time and the safe.
I have heard of few currencies like, for example, Ethereum takes 12 to 15 seconds for transaction process. Okay, and there are many other altcoins which are working on the scalability part of it and increasing the speed. There is another currency called Ripple, which is again bank specific, like for remittance purpose it is being used. Okay, so we have limited time. I think we should move on. So I think we touched base on this decentralization topic, and I hope this is clear. And there are types of blockchain. The Bitcoin blockchain is called a public blockchain because anyone can participate into it. There is no special, permission needed. It is permissionless. Basically, it has its own native asset called Bitcoin. It is open for read-write access. It is slower in transaction processing because it is decentralized. It uses a consensus mechanism called proof of work. Ethereum uses or will use, not currently it is proof of work, but it will eventually use something called proof of stake. It's called the blockchain, whereas the private blockchain is another type, which is a permission blockchain. Okay, so if I want to participate in the blockchain as a miner, as a consumer, as a peer, I need permission. Okay, normally these private blockchains or permission blockchains are built by organizations, enterprises. 3-4 banks are coming together and building their own blockchain for exchange of data, for settling of transactions. In a supply chain scenario, when there is an exporter and importer, and there are intermediaries in between, third parties, customs could be the logistic companies could be there. In those scenarios, all these different organizations coming together and they're forming something called private blockchain or permission blockchain. So where every member of the blockchain is identified, then in that case they have their own asset. They can model their own asset. It need not be Bitcoin, okay? If it is a supply chain transaction, they can model the way they want. There is a permission read write. The transaction processing is faster because it is not going through all those miners globally. The participants, consensus is one part of it. Consensus means the agreement between all these parties, whether the transaction is really valid or not. That's called consensus. So most of them needs to agree whether the transaction is valid or not. Okay, so they can design their own consensus mechanism. Okay, so that's a core difference between public and private blockchain. Platform wise, you can see in public blockchain, Bitcoin, recent fork from Bitcoin is called Bitcoin Cash, Ethereum, Litecoin. These are few examples of public blockchain platforms. And based on the success of public blockchain, few enterprises, top banks, top financial institutions have come together. They have started using the same concept of blockchain for enterprise use cases, and they have started building these projects. Like Hyperledger is again a big alliance built by these top banks, not just banks. There are different kind of companies there, and they are building. It's a project led by Linux Foundation. Okay, and there are around 5 to 6 different kind of blockchain projects that they are building. There is Corda from RT. There is something called Enterprise Ethereum Alliance, led by again enterprise companies like Microsoft, Wipro, and a lot of them. They are building it based on Ethereum platform. Quorum is from JP Morgan Bank, and there are many other. Like these are few examples of public and private blockchain platforms. So what's the invention here? Like we talked about Satoshi Nakamoto and we understood Bitcoin and all that. What's so special about Bitcoin is we need to understand what it is not. That's it, right? It's not a company. There is no CEO to the Bitcoin company. Then it's not an organization where there are employees working for Bitcoin company. It's not owned by a single individual. So all the network, entire Bitcoin network works on the software itself. It's just like a standard protocol, like TCP/IP for the typical network protocol, and it works on mathematical rules, and everyone can participate. In the Bitcoin ecosystem, let's understand if there are transactions. The transaction needs to be confirmed by miners, and while they are confirming, they are creating a new block. Okay, that's called a candidate block. And while creating the block, they need to solve a puzzle, a mathematical puzzle. It's called a proof of work process. I am not going to get into more technical details of it, but let's understand for the sake that there is some puzzle they need to solve, and for that they need to run the computer processing like CPU and energy. Okay, so that's called proof of work, and whoever builds the block faster claims that okay, look, I have a new block ready, and he publishes the new block to all the miners across the globe. Okay, and other miners validate the block whether he has done it correctly or not. So it's a race. It's a mathematical race, and whoever wins, he will get awarded with some bitcoins. People who are already using Bitcoin may know that how many bitcoins are awarded for a new block right now.
Yeah. How many are from accounting background or financial background or commerce background? How many have studied accounting at any point in life? Okay, all of you. So I'll take the journey about what is the blockchain from an accounting standpoint. So I'll explain it not from a technical standpoint as to what it implies in terms of technology and how the technology is validated. I'll take it from the evolutionary standpoint also. So let's look at the accounting. Yeah. Before I start, here is my disclaimer. You can read it. and it's not intended to break any laws by any chance. Whatever I speak is not intended to break any laws by any chance. So let's look at the accounting system. In the early days, let's say 1,000 years back or 1,500 years back, there was a simple accounting system known as a single entry system. In single entry, what used to happen is, I'm having 10 rupees, I gave you 10 rupees, minus 10 rupees, I got 100 rupees plus 100, so that's just the balance was maintained in single entry. It's a linear accounting system, okay? Then, when the trade or when the globalization started in its nascency in Florence, the double entry accounting system was developed in both the parts of the world at the same time. One is Asia and one is Florence. So in double entry system, we have debit and credit, the concept of debit and credit, and the ledger was born. That in ledger, the ledger is self-stabilizing in nature. That if you have given someone, so that balance will be made into its separate account, and basis that we have the balance sheet to be made. Now, when we study accounting in the first stage, what we have is we learn how to write a ledger first. Okay, everyone clear with that? The second thing the teacher teaches us is bank reconciliation statement. Now, what does that imply? That implies that when I transfer, it implies that the double entry system is limited to the entity from the legal system. My books are mine, your books are yours. And because of this limitation, what happens is, you have to settle the books at X amount of time. A trader at the end of the day comes down and sits with his fellow trader and settles the book. Now, this is the problem of the double entry system. Why is it so? It is not a problem when the entity is small. If the entity is like, let's say, a small trader, he will have 100 records. But if an entity is a bigger entity like a bank, if an entity is a bigger entity like, let's say, trading house, it will require another entity to be formed like a clearing house to settle the transactions for all the banks. Because of this, there is a risk that is born, that is systemic risk, which we have seen in the 2008 crisis. That in this kind of clearing house system where the settlement is done by one entity, you cannot look past the transactions that have happened, the clearing house. If you want to know where the money came in this person's account, whether it is valid, yes or no, you'll have to go and check it with the clearing house. The clearing house will know or may not know at times, because of which what happened was the credit default swaps that were traded were junk in reality. So that was the problem of the double entry system, because of which we enter the triple entry accounting system, which is the function of the blockchain. Now, why is it so different from accounting standpoint? Consider blockchain is a peer-to-peer database or peer-to-peer ledger built over the internet. Now, everyone will have the same records at every given time. So what happens in this situation is, by virtue of the book, there is one common book over the internet. Everyone can go and enter in that book, and the interesting part over here, because of cryptography, is the person who is writing the book knows only his color of the pen. He doesn't, and he is colorblind. If I am writing with a green pen, which is my green key, I'll be able to see only green transactions, and I'll be able to transact in only green transactions. So, you have a separation of double entry system, as well as the system is having the same common book. Because of this, what happens is, the automatic settlement is automated. And when you take this kind of system onto a peer-to-peer network, you automatically create a currency. Because the notional value of the value that is exchanged inside that book itself becomes the currency, and that is Bitcoin. And that, if you make a separate network of that into another ledger, which is, and that you may call it as an altcoin. So that is the triple entry system. Now there is one more interesting part, that how does the validation happens. In double entry accounting system, your validation was done every year. At the end of the year, you go and break your head with the CA that you complete my auditing. In this system, they have made the rules of the accounting system very defined, and because of that, the mining or the validation process or the auditing process is consumed or reduced to 10 minutes. In Ethereum, 15 seconds. So the books are getting, this is a ledger, let's say a one common ledger across the world, which is getting audited every 10 minutes. So that's what brings it stability. So that is about Bitcoin in general. Now, moving ahead, one more layer into Ethereum. Now, if anyone will explain Ethereum in its name and language, Ethereum is very complex to understand in the first place. But if I break it down in the accounting terminology, it becomes very simple. In accounting, we have the transaction, and all transactions have a transaction description. In Bitcoin, this space of transaction description is limited to 40 bytes. You cannot store anything more in that. So people try to make protocols on top of that. For example, Patel, for example, Mastercoin. They try to make protocols on top of Bitcoin by editing the transaction description. But Vitalik and a few others realized that this is a limitation. Now, why don't we just remove this limitation of 40 bytes and make it 3 MB? So you can add 3 MB of data onto a transaction description in Ethereum. Instead, and over there, what they did is they put the function of the calculator program or the compiler code. You have a C++ code, you compile that C++ code, and you put it on the transaction description field. Now suddenly, because the nature of the triple entry accounting system, what happens is whatever the program code that is in the transaction description of a transaction is available to all the people on the world. So now, just to give a different analogy, what happens is every time you install a Microsoft OS, Windows, you have calculator as a program on your system. And you can imagine the number of laptops, number of installation is equal to number of copies of that particular code. Correct? So that particular code is replicated X amount of time, and this is another problem of computer science. The problem is integrity. Viruses are existent because of the fact that a code that is there on your laptop or computer is manipulated by someone without your consent. Now, if that program is on the Ethereum network, it cannot be manipulated by anyone because it follows the fundamental of the blockchain, the triple entry accounting system. It is impervasible. You cannot break it. Now, so this is what is Ethereum. Now, since the very nature of the legal structure, now we'll go into the legal structure of jurisdiction and entity. Since the very structure of the legal system is that you will bound a system by a jurisdiction. You will make that this system is pertaining to India or this system is pertaining to this entity. Now, the very nature of blockchain limits that boundary to cross jurisdiction, and anyone from any part of the world would be able to participate on the network without any government's consent. You don't need legal license to get into the Bitcoin world, or you don't need license to be in part of, and that becomes a very big question for the governments as to why they cannot control it. Suddenly, because of this nature, because of this cross-jurisdiction platform, it becomes like the internet. No one can control it, no one can have any sort of control over it. This very nature leads to many new use cases being prevalent out there in the world. Previously, since all the books are maintained by that particular entity, what used to happen is they used to make the people used to make systems which used to talk from one book to other book. Let's say supply chain. In supply chain, you have one database of one company, let's say the importer, then you have the chain of custody that goes on for the produce. That is maintained in each and everyone's database. In the case of blockchain, if there is one common book, everyone refers to that common book, and the rules of double entry presides over all the functioning that happens over that particular ecosystem. So that is how this affects, and because of it, what happens is the use cases that are born out of the blockchain world are very different than what we see in the traditional businesses. One example of it, we had crowdfunding. Crowdfunding was there. We had Kickstarter, and every companies like Kickstarter, Indiegogo, and everyone was doing projects, raising funds from their platform, and that funds used to be given to the maker. But in this situation, the entire code of it was converted into a computer program put on the transaction as a transaction description on the contract. That becomes a contract. Now, if because of the nature of the triple entry system, what happens is that that particular piece of code acts like law. What happened in this situation is you suddenly cross the boundaries of all the jurisdiction. You suddenly have no limitation of entity. You suddenly are able to transact across multiple set of peoples, multiple actors, and you are able to make some beautiful systems out of it. For example, Steemit is one good example of it. In Steemit, what these guys did was they converted the blogging platform into a tokenized system, wherein number of views onto your system and the ad revenue that is generated by the ads on that particular blog are given to the maker of that blog, the contributor who added things for that particular blog, and certain part is taken by the pool. So in the system, no one is actually present sitting in their office doing any work, but they have just made the system once, and that is running for eternity over the blockchain. So this is what is all Ethereum about. Now I'll leave it to the crowd as to any one segment of industry which they would like to take. Healthcare is one. Anyone else?
Energy.
Energy is again.
Real estate.
Real estate.
Farming.
Farming.
Banking.
Which one?
Banking.
Banking, I think triple entry would cover it. I will not go more deeper into it because banking is already destroyed by just the idea of triple entry.
E-commerce.
Let's take entertainment industry. Okay. In entertainment industry, the use case would be something like there is a maker of the content. Maker of the content is an actor. So there are multiple sets of makers on the market. There are a set of broadcasters who will broadcast that particular content out to the public, and there are consumers. The consumers are there, and there is someone who is advertisers also. Okay. So there are two types of content. One is paid, one is free. Free one is entitled to advertisements. So advertisers will pay some money to the framework that we want certain advertisements, and if the advertisement is viewed by the person, the advertisers pour in their revenue to the pool. So now let's take this as a computer program on the blockchain. Okay. In this situation, you will have one. Whenever a maker makes an application, makes a content and puts it on the blockchain, he is entitled to the rights of that. He will have the option whether that particular content is to be kept open, closed. If the viewer pays it, directly that amount goes to his account by virtue of the pool contract, and that all denotation happens in its specific coin or its specific token, as we call it. And now that can suddenly be cross jurisdiction. When you raise an ICO, you will have to be domiciled in one location, that may be a country. But post that, once the application starts, you are cross jurisdiction. What happens is when you go in this kind of situation, the broadcaster also will have some rights. That the broadcaster will take some amount of fee. So that is predefined by the system. For example, let's say if a content is broadcasted on the media network, then that is having 30% charge. So that is predefined in the contract, in the smart contract. And this entire structure is over the blockchain. Any other case?
So a block in the form of a contract.
Yeah.
The blockchain is executed when it gets complete. If there is a contract which is not fulfilled, so what happens to a particular block?
Okay, I'll go to one level deeper into that question. Is let's say if the contract is a computer code. So computer codes will have a specific set of interfaces. Will have a specific set of interfaces that you can talk with a computer code in this particular language or this particular manner only. If you talk anything beyond that, it will be dumped. You will not be able to utilize, if you have sent let's say 300 ether to a dump wrong thing in the contract, you are lost. your money is lost. It is your onus that you have to ensure that it is on the correct area. So by virtue of the definition of the computer program that is put inside Ethereum, Ethereum has its own EVM, that is Ethereum virtual machine, that is 8-bit processor that runs this computer program, and that has certain specifications. Once you upload it, it will give you a specification called as EDI. You have to interact with that contract in that particular manner only. And since it is on the blockchain, everyone will have access to it. That's something that's understood. Yeah, one more important part is you have, let's say you have uploaded 3 computer programs onto the blockchain over the triple entry, and all of these 3 contracts are talking amongst themselves on the blockchain only. So that is the functionality of Ethereum. You can have 3 contracts. Let's say we have made entertainment industry also on the blockchain. We have a real estate industry also on the blockchain. Suddenly someone has some huge amount of tokens of entertainment and wants to convert it to real estate. Someone can make an application of that also. Because both of them are on the blockchain. Both of them have specifications that are out there, and both of them can interact on it.
So how ICOs can be a fraud?
ICOs can be a fraud in situations wherein the development team itself is not liable. For example, there are a few coins. Matchpool is one of the examples where the founder itself vanished, ran away. And for that, you need to ensure that wherever you are investing in an ICO, you need to be doubly sure that do they have a multi-sig wallet, do they have what is their governance structure, what are they talking about, do they know? So most of these ICOs, they open their Telegram channels, they open up their Slack channel. You need to go and talk to them as to what they are doing. Are they real? Are they fake? What are they doing? Because in the situation of ICO, even if a country says they are banning it, by virtue of the blockchain, they will not be able to go and outrightly ban the situation, because it's like you're talking about banning the internet on the whole, which you cannot. Create blockchain. Blockchain can be created by virtually anyone. You can also start one.
Even if it's not a, like, I'm not a technical person. And
Virtually, if you want, you can. It's like the code is available. But only thing that would matter in the creation of a blockchain is the amount of participation. How many people are onto your network? How many people are you having as running nodes?
I can invite, right? Invite people to.
You can invite, but running a blockchain is not an easy effort. It's a way more tedious effort.
So it is easier to outsourcing. Huh? Outsourcing, or you are advised to transit in particular whatever the blockchains available, right?
Yeah. Yeah, you have a question?
Yes, sir. So now there are wallets in India specifically. There are wallets which only trade in bitcoins. They don't do trade in others. So legally, is it possible for me to open a wallet somewhere else?
You can have a look at Jack's wallet. Jack's wallet is having the keys on your mobile. So if you open a Jack's wallet, the keys are on your cell phone.
So legally, like from Indian
government point of view,
is it legally advised to do so?
Indian government has given no such statement. It is a warning statement. The statement of Indian government is more on the lines of giving a warning to public that do not do it, because by virtue they cannot stop it, and if they make a law, it will be not the advisable law. They'll go and stop the exchanges, but if the exchanges are stopped, the exchanges will move to somewhere else. Yeah.
So there was some news that there's upcoming they are bringing a Indian cryptocurrency actually.
Yeah, I think that's a fake news, firstly, because Indian government, if they are working on a separate digital currency of their own, that would have question of jurisdiction and sovereignty of the entity. For example, if Indian government makes it and says that okay, this is valid only in India, but since it is peer-to-peer in nature, a person sitting in Pakistan, a person sitting in Afghanistan will also be able to use it. What's the point of it? And that would outrightly be a violation of AML laws that Indian government has said that Indian financial system should not interact with anyone from the enemy state.
Correct.
Yeah.
It violates favor.
Yeah, it won't favor. Now, and government would never do such a thing. And even if they do, they would be struggling with their own laws over there. And that's a bigger point of debate across multiple countries and across multiple central bankers across the world. It's not just Indian phenomenon.
So can you tell us about use of blockchain in stock exchanges? Stock exchanges, that now they are saying that as it is centralized, that if you are transacting with NSE, so the rates of stocks change constantly. So the nodes located near Delhi area receive faster updates about the
In this particular case, blockchain for exchanges is only used for asset management. So you create a template like just an ICO model. ICO creates assets in form of tokens. Now that token management framework is of utilization for stock exchanges, not for. It cannot be used. It can be used for settlements, but real-time order matching is decentralized exchanges, which the current area has not evolved for them.
Is there any I'm giving certain IT services to the outside of the world, outside of the market, and in terms of service, I can get bitcoins or any cryptocurrency. So, is it legal? I can justify when I converting my bitcoin to.
Yeah, it's a moment you transact with people like the moment you convert your crypto into fiat, you will have to pay a certain amount of GST tax and all that taxes. So it's like how you take it in your books that much.
Use of blockchain in energy industry?
Yeah, in energy, there is one interesting use case. There are two companies which got my attention over there. One of them is Transactor Grid. Transactor Grid have made micro. For example, let me just give the case in a different way. In energy, you have implemented a solar plant or solar cells on your rooftops, and in the daytime you are not in your homes, and that solar cell is directly connected with your local grid. So now the entire grid management at a local level, not at a global level, at a local level. For example, in Gujarat Dwarka area, we have tremendous amount of local wind power being generated, local solar power being generated. So you can make that application wherein the load is not shared to the power plants and the transmission cost is reduced in real time. So during the day, people don't stay in their homes. During the day, they go off to work, their home solar cell is generating power, and that is given out to the grid. That entire management can be taken off to the blockchain. That is the use case. That entire load management power, load management gambit, because you need smart grids over there. If it's a smart grid, your functionality becomes much more efficient. So that is a use case over there.
What's the name of the company?
Transactor Grid. It's a Swiss company. Exactly, that's what I mentioned. They would go and control the exchanges. For example, in the Indian context, they would go and control ZK or Unacoin or some other exchanges, but they would not be able to control the system as such, because there will always be some person in some part of the world or some other country which would be keeping the nodes alive.
They can transfer fund outside and they can purchase Bitcoin and then.
Yeah. So that mechanism cannot be stopped. it has moved certain threshold.
Yes, they can stop exchanges, but
Yeah, they can stop exchanges. Now the system has moved certain threshold where it cannot be stopped by any country. The system level dynamics has been reached.
System works in you can transact anonymity. That's what the Bitcoin platform is. So how do you know that the transaction is being used in India or
There are mechanisms. There are mechanisms for that. So that's already in place.
Similar question to the right? So once you are done with like now you felt okay, you don't want to do any transaction with the Bitcoin anymore. You have some balance in your wallet and you want to sell it up. How do you do it?
It's wallets. We use the wallets. You use the wallet part itself. So the wallets are the best ones.
It will be in your bank account then the conversion.
That happens via the wallet. So the wallet is responsible for it.
Wallet of the particular platform.
No, it's Uno coin or Zepay. That particular part will be responsible for conversion into rupees.
The exchanges will help you.
Yeah.
Go to the exchange and they will help you convert your currency. Yeah.
The Bitcoin value into the INR. Yeah. Right. And then it will be credited into your account. Of course. Yeah. So that's what I'm doing.
However, I'd like to take the discussion into the private consortia, wherein let's say there are 5 banks which are coming together and coming to consensus just as use case. Let's say there is a segment where a private blockchain can be the application. So it's like there are certain cases for that, wherein you use the entire blockchain technology or the EDI accounting system for settling a particular use case or a particular pain point in a specific industry or a specific government use case. For example, governments do have a problem wherein multiple departments want the same set of data, but they're not able to produce that data. Or you have the settlement problem amongst the banks itself. You have the KYC problem, which I worked on, that KYC cannot be shared amongst multiple parties. So that can be used. That's one use case for it. Then there is another use case wherein you have bills of exchange. These are trade finance. What I mean by trade finance is, let's take that use case into depth. It will be much more of interest. In a SME segment in India, there are not many traders which are having unpaid bills or due date bills that are yet to be paid. Payment will be received in 14 days. And that entire mechanism is where the cash of that particular trader is being blocked. But how about we make a small use case, wherein let's say there are in Kalupur area of Ahemdabad, all the traders are entering into one small blockchain consortia, wherein all the bills that are being generated are settled by one bank who is acting as a liquidity provider, and that bank knows as to how much is the credit worthiness of that particular trader in that vicinity. So to basis this virtue, the liquidity crisis within that small group of people or that small collaborative community is solved within a jiffy. Did anyone get what I just did in this use case? So I made a small private blockchain within a small community in some part of the world, and they will be trading their unpaid bills, and one person will be acting as a liquidity provider. The rates are defined by how much liquidity that liquidity provider has. For example, let's say Kalupur Bank. Kalupur Bank is having 10 lakh rupees just as a liquid fund, and they will be willing to give it out to people at 3% a year. And if you make that entire mechanics, and that cash management is on the open ledger, everyone would want such kind of system.
From accounting point of view, if a person doing 100% transaction through Bitcoin and all, so it does not fall into the income tax and all the taxes.
It would fall because at the end of the day, its amount is coming into your bank account. It's not coming to you in cash.
See, today I have 1,000 Bitcoin in my account, right? I have given 200, 300 Bitcoin to some.
Bitcoin to Bitcoin would not be taxed. Bitcoin to INR will be taxed.
So that's not even Bitcoin to Bitcoin account. So that's what I said. 100% transactions through Bitcoin, so it won't be trapped, right?
if you are on the, if you are trading, if you are transacting on the wallet itself, where the transaction log is available to the government, then you will be tracked. If you are on,
Someday you have to.
yeah, at the end, it would definitely come down to your balance where you have to disclose it. That disclosure part will not be done off.
If you sell some product and you
Yeah.
receive the fund in Bitcoin, so you won't have to pay tax. If it's a particular time it remains in your wallet or,
Yeah.
but when you convert it into bank,
Exactly.
you would
At
have
one point
to
it
show
will
the
come back.
amount and you would have to pay the tax.
At one point it will come back, and you cannot be totally anonymous because the system is such that either at any point in time a person will come and use exchange wallet like Unocoin or Zepay, or let's say some other currency, some other wallet. Suddenly you will have a system wherein it's like you have the regulation will also evolve to this. Regulation will come to this level. It will not be totally anonymous. Regulation will also evolve to the level where it has evolved for SEBI. SEBI 20 years back it was not like that. 20 years back, people or any CA could do a transfer of share from party A to party B. Right now, it is not the case. The government stepped into the regulation and that okay, if this happens, this has to go in this way. Either it may come by an international convention or it may come by a local convention. If an international convention comes, the parties like IMF and big banks will come into state that okay, if any party is dealing as an exchange with fiat, they will have to deal in this particular manner. So that will be bought in. That will come in, but it will take a time. It will take time for parties to understand as to what is the system dynamics of it.
Bitcoin to Bitcoin is not traceable and
Taxable.
taxable and traceable.
Right now it is not, but gradually the regulation will come to that level. It will evolve. It will evolve. It is what
It is traceable right now, but not taxable.
yeah, as I mentioned, the triple entry accounting system.
So, government
It is a decent.
It will be involved with how many Bitcoin you have, you earn, and tax on the present rate they will tax.
Yeah, so that mechanism will be devised because here again the factor that the economics of both the worlds. Bitcoin is talking Austrian School of Economics, where your currency of fiat is talking Chicago School of Economics. Both the school of thoughts are different. One is saying deflation is good, one is saying inflation is good. So now it's ideologically it's a fight of looking at it's a fight of philosophies. The two extremes are trying to fight. It's like communism trying to fight with capitalism. One edge is going more towards like let's say if the community is bigger, more the valuation. Other is saying if I have more, I will become bigger. So that is the talk over there. And in Europe, it's again a beauty for us as Indians that we have faced both the worlds. We have seen the extremes of communism. We have seen the communist era during Indira Gandhi, and we have seen the capitalist post 1991. So we have seen both the worlds. That's in our benefit also that we will be able to understand this world more better.
So can you talk about some of the companies in blockchain which are already disrupting like this co-founded, Stratus, Waves, in which sector they are doing and what are they doing?
Okay, one of the biggest disruptor that's how the ecosystem is structured. Also, from the consortia standpoint, R3 has done some good work. Algorithmics has done some good work.
What are some good projects?
Good projects.
Dave browser, Patel.
Project-wise, Steemit is there, BAT is there, Civic is there.
Yes, sir. If you could explain these, what is that and
Okay, that would take a lot of time because each project is a use case in itself.
so that we could also get ideas कि हाँ इस industry में हम लोग भी ऐसा कुछ कर सकते हैं.
Okay.
Because at the end of the day, we are all sitting कि we want to start something in blockchain.
Okay. Steemit is let's back. I'm not much aware about because I'm not more into the tech. I'm more into the tech of let's say quantum. Quantum is is a blockchain where they are trying to merge the protocols of Bitcoin to Ethereum. Whereas in Bitcoin you are having a limitation of transaction size, transaction description field limitation you are having. Ethereum you are not having. How can you run a compiler code on top of such a system wherein it's on the same Bitcoin protocol? So that is what Quantum is doing. Then you have a project like Transactor Grid, I've already mentioned it. It's on energy. Then you have Singular DTV. Singular DTV is the media markets over blockchain, but that uses the same fundamentals for content sharing as DRM over the blockchain. So what I mean is, let's say you have made an ad. Now that ad is broadcasted by Netflix, or a content or a video file that is broadcasted on YouTube. Now, if X number of people view your video, you will get certain amount of token. For example, let's say there was a video which was very popular, Gangnam Style. Many people viewed it. How much did the maker get? Maker got a lot less amount because it was controlled solely by Google. So there are some platforms which are trying to disrupt this particular market, wherein video is made by a content maker is uploaded on their platforms. How many people view it? The amount will be deducted and given out in fair ratio. So the pool gets only 4% or 5%, wherein YouTube, the pool takes in more like 50 to 60% of the content maker's rights. That's a fight over there. Same going with a concept like match pool. We have seen applications like Tinder. Tinder is a matching application. Parties matching up. You have that kind of algorithms can be used for job application matching, for something like Quicker also. Quicker takes no cut in the situation, but in this situation, if two parties match, both the parties will have to pay some amount. Let's say I'm a home seller and someone is a home buyer of the home. Then for the entire deal amount, someone will be given as tokens to the system that they are providing this kind of service. So that is match pool. Then there is a service, then there is a use case like you have, I forget the name of it, for real estate. In real estate, there's a company from Netherlands. These guys converted co-working space into, they tokenized the co-working space into the blockchain. In this situation, what happened is, if the co-working space is being utilized by someone, then the owner of the space, or let's say the investment done in buying the space has 100 seats, out of this 20 are blocked for a month. Then whatever the revenue derived for that particular seat is directly distributed to the token holders. So this is what these guys from Netherlands have done. They are making co-working spaces across multiple regions. Their rates would be very standardized, and whenever they come out, so if a person goes and buys a co-working space, that amount is directly deducted from their balance and paid out to the holders. So this is one area. I don't recollect the name. I'll just give it to you. Any other area which anyone wants to take up? I'm open for that. Or any questions?
So this blockchain applicable everywhere? Not as everyone is doing it.
It's over there. I'd say that it's. I would contradict that problem. It's a use case. You have to look at how many people are participating, what kind of actors you are inviting to play in the blockchain space. You make a blockchain just for the sake of making it does not make sense. Some of the use cases are like that, so that's why people are saying it's in a bubble situation. But it's more advisable to understand the ground realities of the project, whether the project is really worth that. And that is also a big question when it comes to actual implementation. That is why people are saying that it is in the bubble territory right now. Okay, token into the business model is something like how do you integrate the token? let's dig into the model of steaming a bit. The content maker. So that's where the entire architecture piece comes into play. The content maker. Let's not take it in the steamer. Let's take it in the context of 10x. 10x is a company which was there in City Mobile Challenge also. These guys issued a card. You can get a 10x card. You get a 10x Visa card. You can go and swipe it, and the amount to the merchant will be paid in normal fiat, and the value of 10x is in your crypto balance. You are holding Bitcoin, you are issued a card, you swipe the card, your Bitcoin balance gets deducted, and that entire denomination is in 10x token. If you have 10 10x tokens, it is equal to $10. You swipe $1, $1 worth of Bitcoin balance is deducted, and that is automatically converted by our atomic swap and other mechanism is directly converted into your 10x tokens. Or either you go and convert your Bitcoin directly into 10x tokens, and that 10x token will be utilized by your card. That is how tokens can be integrated into your use case.